Alrighty, let's do this real quick. So we are in our last week, week 15. Week 15 talks about classes and object-oriented programming, which is the syntax for which is very similar to what you have in Java. If you've done Java or if you're going to do Java, this is pretty much what it's used here. So first of all, what are these classes and objects? Well, we already saw from the previous week that we had something called structure, right? And what was a structure? A structure was a way for us to group a bunch of variables into some kind of a named entity, right? So that was the structure. There was no predefined way in which I can change these variables. You can pretty much directly access them using the dot. And so if you have some kind of a structure called part, then if you wanted to change the part name for that structure, is just part.part name equals some new part name, some new string. Okay? But if I decided to, say for example, change the count of this part, right, to some kind of a non-numerical, symbol, right? Maybe not a number, maybe not even a string, some crazy symbol that I accidentally typed in. There's no way for me to catch that with a structure, or at least not with a traditional structure. So the way we're going to handle this is basically the way we're going to change the properties of these named entities is using actions, which are the functions. Okay, and that's what's going to happen with objects and classes. Okay, so I have a whole bunch of stuff in there with some examples and explanations, but if you look at if I zoom in on this thing, you're going to see that there's a P71 class example CPP in which you have an example of a class. So just like you have a structure, right? So structure, the name of some structure. Similarly to that, in line 3, you have class and then the name for some class, right? So this particular class is called a dog, and everything that's inside of the curly brackets, which is between line 4 through line 24, is part of that class, right? What is a class? Class is a template for an object, right? So objects are created from these classes or templates. How are we creating these objects? If you look at the main in line 30 and line 31, we're creating two objects. One object. Also, creating objects is also known as instantiating, and these objects are also known as instances. Okay, so the instance name for the first object, which is on line 30, is Labrador, right? The instance name for the second object, which is on line 31, is German Shepherd, right? So those are two objects, right, or two different instances. Every time you create a new object, you're instantiating. Okay. What happens is, so on line 30, and by the way, this is this concept of how you create an object and you give it an initial values is similar across different languages. It doesn't matter if you do Python, if you do Java, if you do any object-oriented language, any object that supports object-oriented programming is going to work the same way. So what happens is in line 30, we're creating a new object called Labrador, and inside the parentheses, we're giving it an initial value, right? So this value of 20 is going to be passed into the default constructor, which is what you have in line 11, right? On line 11, you have dog, parentheses, float new weight, right? This is the default constructor for the class dog. What is a constructor? Well, it's like a function, but it has the same exact name as your class, right? So class name on line 3 is dog, constructor name on line 11 is dog, right? Same exact one. Now you could have multiple, you can have one parameter inside of the parentheses, right? In this case we have new weight, that's my parameter name. You can have 0 parameters, you can have 2, 3 parameters, there's no rule, right? As long as your constructor has the name of your class, that's a constructor, and then the number of parameters that you put in it's up to you, up to what you want to do with it. Okay? In this particular case, I want to have a new value, or for the weight, as soon as I create a new dog object. So on line 30, I create a dog object called Labrador, and I'm sending 20 as the argument, which gets passed over to the constructor, and the parameter new weight becomes equal to 20, and I change weight, which is the property, the private property of my dog object. Okay, why is it private? So that you don't accidentally go in there and mess with the variable. So that you can't just go and do the dot weight equals something. Okay, just like we had with the, remember how we have a structure and the way you access the variables inside of the structure is with the dot? Well, the reason we're doing private here is so that if you were to ever use this class, you cannot accidentally directly access the variables and maybe accidentally change them to some value that you shouldn't, right? Even though in my constructor, I don't really have an if. Maybe I should have some kind of an if, like, well, if the value is positive, maybe, or something like that, or the value is less than 500, or whatever the max value for a dog could be, I guess, right? So there should be some kind of an ifs in there in the constructor to make sure that you only give it a, good value, and that's kind of the purpose of these actions, right? So the constructor is part of the set of actions that this object has. What are the actions? The actions are the methods, the constructors, the functions. Oh, by the way, once you put a function inside of a class, the nomenclature is to call it a method, right? You can call it a function, I don't care, right? It's pretty much a function inside of a class, right? But if I call it a method, you know what I mean, right? It's a function inside of a class. Okay, so all these different methods or functions are ways for you to change the property of the object. The property is the weight, right? The variables are the properties. The functions or methods are the actions or the ways we're going to change these properties. The way we're going to change them, the way we're going to see them, right? At least every object should have, a couple of, different kinds of methods, right? Obviously, it should have a constructor to give it initial values. It should have methods or functions to display the properties or display the variables, and to change the properties / variables, right? So at the very least, you need to be able to see the weight of a dog, you need to be able to change the weight of the dog, and then you need to be able to create a new dog with a certain kind of weight, I guess, okay? So those are basically the kind of, at least the minimum, the bare bones of the functions that you need or methods that you need for a class, right? So you need a way for you to give it initial value. That's the constructor. You can have multiple constructors, right? You can have one constructor that has a single parameter. Then you can have another constructor that has 2 parameters maybe, or 3 or 4, right? So multiple constructors for each class are allowed as long as the parameters are different. Right, so I can have one constructor with a float parameter, I can have another constructor with an integer parameter, but I cannot have 2 constructors with one float parameter because it will get confused. It wouldn't know which one is what. It's like overriding the signature of the function name, basically. Okay, so what else? So that's basically the different terminology that you need to know. Right, as soon as you create a new object, again, on lines 30 and 31, you're instantiating, you're creating a new object, you're making a new object of this class type, okay? Each object is going to have its own set of variables, which means that every type of dog that I create here, Labrador has its own weight, and the German Shepherd also has its own weight, right? They're completely independent of each other. If I go and I change the weight of the Labrador, the German Shepherd's not going to change its weight, okay? So these are one kind of variable. Those are called the instance variables because each instance or each object has its own individual set of these variables. They're independent from the different objects. There's other kinds of variables that are shared between the objects. What I mean is if you have a bunch of dogs, there's maybe a kind of variable that keeps track of how many dogs you have. And if you change that number for one of the dogs, it changes for all the different dogs. There are those kinds of variables as well, but I'm not going to go into that kind of stuff really. Okay, more of that in the Java class. That's why I highly recommend take the Java, because it will really expose you to that dictionary so you can understand it by doing these things. And again, why we have private and public? Well, public methods or public functions, right? The constructor, the methods that allow you to change the weight and see the weight, they're public because we want the public or the world to be able to interact with my dog some way, right? So these are basically your interface with the class, if you want to think of it that way. There's another, there's a special thing called an interface, but I just like to use the term interface as, the description for what these are, right? It's how you interact with the object. It's the same way your remote control is the interface with your TV, right? You don't really know the details of how the TV works. You just press the buttons and the volume goes up. Well, similarly, that's the idea of how these objects are organized, right? If you create some super complicated class to solve some real-world problem, and then you give it to the next programmer, you want the next programmer to be able to just press the buttons and solve the next similar kind of a problem by just pressing the buttons instead of trying to reinvent the wheel and figure out how the TV works. So that's why, that's basically your interface. That's your methods. You want to have them well documented. So on top of each method, you need to tell maybe what are the prerequisites, what needs to be true before you call this, and what's going to happen after it's done. It's magic, right? On top of each of these methods, constructors, right? So good documentation, very important, so that whoever's using your stuff knows how to use it, right? I don't want to have to go and look at the details of the function to figure out how I'm supposed to use it. I want like an easy to follow steps. You plug in this number, and if this number is between maybe this and this kind of value, it gives you some kind of a result, right? Give me the summary of how to press the button so that I can easily recycle your code. And that's another idea behind object-oriented programming, is being able to recycle your code and use the properties of already existing objects, basically inheriting properties, right? Once you have some kind of an object for a circle, and if you wanted to build another object for a cylinder, you don't have to literally reinvent the wheel. You can tell the cylinder object, look, you can inherit the properties of the circle, just add a height to it, and now you can make a whole new object called a cylinder. And so you can tell the cylinder, inherit the properties from the circle. That way you don't have to reinvent the circle. And this is useful when you start doing graphical user programming, GUIs, right? Especially in Java. If you take the Java class, we're going to start doing a whole bunch of objects. So it's like you have a container object, and then that container object, you add other objects into it, right? There's like hierarchy, but it's all already built into the language, right? You just get an object for a button, and you change its properties. Oh, I'm going to change the color. I'm going to change the text size. I'm going to change the width and the height. But it's still, it's still the same object that somebody already invented, right? So rapid development, easier, it's easier to maintain. So there's a whole bunch of other things to say about object-oriented programming, and I will continue this topic in the CSIS 46 class, which is the next class to take after this, except if you can take Java first or at the same time, that will be a good thing to do. I highly recommend that. Okay, so all these terms that I talked about are in here, right? It was a lot of words, and I hope it makes sense, right? And there's some examples in here of, creating objects and calling the objects functions, also known as methods, right? To see the properties and change the properties in there. And let's see if there's anything else I want to tell you. Okay, yeah, so there's a couple of examples in there. P73, class and object example. There's some examples, type them up, get it to work. The other one is, use the previous program to create a new class, right, called human.
it needs to have this property, it needs to have these methods. So you need to know what's a property, which is a variable, right? What are methods, the functions, right? And follow the example to create a new class, basically. Create two instances, right? So you're going to create two objects, just like we saw in the main, right? Give them some values. One is going to be called grown up. That's the first object name. The second one is called a child. They all have a different age. And yeah. And then you have to change the age of the child to something else. And that's it. So it's baby steps, object-oriented programming. Yeah. So for me, it was very important to have, to nail down the basics in this class, which is why we did a lot of, these, input and output, ifs and elses, repetition, right? The arrays and all that good stuff, the functions. For me, if you understand these basics, the rest of it falls much easier into place. It's a lot easier to understand data structures once you get your, array basics down, basically. Okay? So if you want more programming experience and you haven't done the Python class, take the Python class too. I think the more programming you do, the better you get at it, just like with everything else. So do more. That's what I did back in the day, and that's how I got good at it. So some of you are good without even having to do that much, but most of us are not. So that's the idea. Any questions? Finals are next week, which means we technically don't have classes. There is a certain schedule of finals, right? There is it's supposed to be on a certain time, on a certain day. But since you have a take-home final, what I'll do is I'll just be in my office hour during the regular class time. We're not going to have a class. We're not going to be here next week. But I will be in my office if you need me. Okay? During the regular time and my office hours after that. So if anyone needs to catch up, fix that final project or whatever you got going on, come over. If you're not at least halfway done with the assignments, I feel for you. All right? So that is basically all there was to tell you in the first C++ programming class. Could I have put more stuff in there? Yeah, I probably could have done more pointers, more classes in object-oriented programming. But again, I feel like you got to master the basics and the other stuff becomes easier. Okay? So, are we good? All right. Very good. I will stop the video. Send me your emails if you have any questions. You know the drill.